can classify triangles by two ways, okay? By sides and by angles. When it says like classify something, we'll never write numbers, okay? We're going to either write 3 different options for your sides or 4 different options for our angles. What does scalene triangle mean? There are how many congruent sides? None, right? So we have no congruent sides. You guys actually don't need your packets today, so if you want to put them away to clear up some desk space, you can. All right, my second triangle, I have 2 congruent angles. 2 congruent angles, tell me what's the name of that going to be? Isosceles. Isosceles triangle will have 2 congruent sides. And in the last one, I have 3 congruent sides. What is that going to be? Equilateral. I have 3 congruent sides. All right, so on your paper, you'll see that there are 3 ways to figure out the angles. We're going to add a 4th way. All right, the first one, let's say that this angle here was like 100 degrees. What type of triangle would that be? That would be obtuse. So if I have an obtuse triangle, that means that I have 1 obtuse angle. All right, my second, if I have this block here, this square, that tells me it is a right triangle. In order for it to be a right triangle, I have 1 right angle. Let's say that this angle here was 80 degrees. Joseph, what kind of triangle is that?
Acute.
Yep. This would be acute. And so you need, actually, you need 3 acute triangles. Acute angles, sorry. All right, and at the very bottom, I'll try to squeeze this one in here. I have it on the board there, but let's make an equilateral triangle. Sorry, equiangular. I don't know how that was left off here. But if it's equiangular, I have how many congruent angles? 3. This is equiangular. So you have 3 congruent angles. So like I said, we're going to use this for units 4, 5, and 6. So there's going to be some empty spaces for a little bit, but by the end of second quarter, we'll have this whole thing filled out front and back. Let's skip around a little bit. If you look right above this triangle symbol, it says the sum of interior angles of a triangle equals what? 180. We have to know that. That's my magic number. The sum of my interior angles will always be 180. And I wrote this on here twice because it is that important. Your triangle sum theorem over here, the sum of the measures of the interior angles is 180. Maybe if you write it twice, it'll stick in your head. And then under that, the corollary to the triangle sum theorem. The acute angles of a right triangle are complementary. We've talked about this, but we actually just kind of use our triangle sum theorem to figure those out. If I have two angles, I always have a third. All right, exterior angle theorem. What that means, if you look at 1, 2, and 3, which one is your exterior angle? Right? You guys notice that 1 is exterior, right? So that means that 1 is equal to the opposite interior angles. So we're going to write the measure of angle 1 is equal to the measure of angle 2 plus 3. All right, as of now, that is all you can fill out. Oh wait, no, there's not. Look at the very top, where it says about sides. Side plus side must be greater than your biggest side. Let's put that little greater than symbol right there. All right, that's all we can do for now. Are you guys going trick-or-treating tomorrow? No? My first period, we were all talking about that, and I didn't know that you guys still did that. All right. Last year, I had a lot of high schoolers come to my house, so. All right, so let's, oh, you guys don't even have this yet. All right, so this class test review is going to look exactly like what? Your test, which is next class. Kenzie and Michael, your papers are in that group. Three and then go backwards. I literally typed up this class test review by looking at the test. Okay, so I went step by step. It's not the exact same with numbers, but it looks just like this. All right, for number 1, they want us to classify each triangle by the angle, by the side lengths. Everyone listen to me when I say this. We should never be putting numbers or degrees in these spaces. Does that make sense? All right, look at your green sheet to help you. When it says classify by sides, if I have 3 congruent angles, what's wrong with my sides? Are they also going to be congruent? Yeah. Which classification means 3 congruent sides? Equilateral, right? It's equilateral, we're talking about my sides, they're all equal. What about 3 congruent angles? Equiangular. All right, number 2. This is where I don't want you guys to write your sides are 3, 3, 5. Okay, I saw that on your quiz. That is not what you're doing here. If you look at your green sheet, my sides, there's 3, 3, and 5. There's how many sides that are the same? 2. So what does it mean if I have 2 congruent sides? Isosceles. Someone earlier asked if I take off for spelling. No, because you guys butchered this word isosceles. But now that you have your cheat sheet, you should be able to look at that and spell it correctly. All right, number 2, how do I classify it by angle? It's a right angle because I have this square here. anyone writes 90 degrees there, I'm gonna lose my mind. Make sure you're writing the actual word. All right, the third one. I have two congruent sides. What's the classification? Isosceles again. And my angle is obtuse. Over 90 degrees, so my angle is obtuse. Any questions on how we're going to classify our angles? Should there be any problems, especially if you have this cheat sheet to rely on? Good. All right, 4, 5, and 6. Let's take a look at 4. You guys recognize that I have two triangles here, right? I highlight them just so you can tell the difference. All right, look at the yellow triangle and the blue triangle. I need to fill in those missing angles. First, you guys recognize that the 1 and the 2 here are not measurements, right? I don't have a degree symbol there. That's just telling me that that's angle 1, angle 2. That's how I'm naming them. Should I start with the yellow triangle or the blue triangle? Yeah. Yellow. That little square there tells me that it's what? It's 90. So if I have two angles, I can always find the third angle. What am I going to do to find the measure of angle 1?
180 minus 90 minus 20.
180 minus 90 minus 29. Because we know that interior angles is always 80 degrees. Sorry, 180. What do we get for the measure 1? You have to make sure you're typing this in yourself. Don't wait for someone else, because I want you to be able to practice it. $61 degrees. Good. All right. Measure of angle 1 is 61 degrees. If we look at my blue triangle, do you guys see vertical angles anywhere? Look at that 90 degree. You see how it's like directly across from each other? Yeah. So this is technically a right angle too. So now can I figure out the measure of angle 2? Yep. 180 minus 90 minus 48.
42.
Okay, you should get 42 degrees. Any questions on that one? On number 5, we have X and we have Y. Which one is my exterior angle? X, it's on the outside, right? So I know that X is going to be equal to my opposite interior angles. Okay, that's my exterior angle theorem. What is X going to equal?
100.
What did you say?
100.
Careful. X is equal to my opposite two angles that we just add together. What's 60 plus 30? You should get 90. So the measure of angle X is 90. So this guy is 90, and I know that X and Y are a linear pair. They're side by side, so they have to add up to equal 180. What is the measure of Y going to be? 90. You can do it that way, or you can do 180 minus 60 minus 30, and you still get 90. So you can look at the linear pair, or you can just take the interior angles. I think it's easier just to always take the interior angles.
So you add up the angles on the inside to get the ones on the outside?
Mm-hmm. All right, look at number 6. The interior angles have to equal 180. How do I find the measure of A? 180 minus 60 minus 60. And what do you guys get? you get, Joseph? Yep, you should get 60 degrees. Are we understanding the whole 180 thing? Okay, if we have two angles, we can always find the third angle just by subtracting. All right, for question 7, 8. Answer the question using the correct vocabulary. An equiangular triangle is also equilateral. Those go hand in hand. Equiangular is also equilateral. And if a triangle has two congruent sides, then it also has two congruent base angles. Once you're done writing that down, go ahead and turn the page and then get your computer out. I'm going to start that mess. Alright, so, while you guys are still loading up Desmos, you see that I have 3 interior angles here. These 3 angles are going to equal what? 180. Because this guy here is 90 degrees, right? So I have 4x plus 7 plus 8x minus 1 plus 90 is going to be equal to 180. Typically what we would do with this is we would combine like terms, and then we would solve for x. If you are struggling with solving, let's pull up Desmos. Alright, so let's go ahead and type this in. 4x plus 7, can you guys see? Plus 8x, what's that, minus 11? Or minus 1? 8x minus 1. Don't forget the plus 90. What else do I need here? What is it equal to? Equal to 180. Once we do this, I'm going to zoom out, depends on however your grid is set up. What is my x value here? 7. You guys all get that? Alita, you good? Caitlin, you good? All right. So let's go back to our notes, and I'm going to write x equals 7. All right, let's keep Desmos up. For number 10, I have 2 congruent angles, right? I have 2 congruent sides. That's my half parts meaning. If I have 2 congruent sides, I also have 2 congruent angles. So right now I have 6x plus 5, 4x plus 3, and then nothing. What goes in that spot of nothing? 4x plus 3, because that's my base angle. And those 3 angles together are going to add up to equal what? 180. So let's type it in. So this is a good thing, is that Desmos does not tell you how to do it. Like, you still have to know how to type it in, but it can make your life a whole lot easier. So 4x plus 3 plus 4x plus 3 plus 6x plus 5 is equal to 180. I'm going to zoom out so I can see my x. What do you guys get?
Yeah, decimal.
Okay, a decimal's fine. What's your decimal?
12.07.
Good. You should get 12.071. So I'm going to write x is 12.07. I like to round to do 2 decimal places. If you wrote 071, that's fine. If you just wrote 12, that may be some points off, because you still have to round at least something, so I know it's a decimal. All right, number 11 is tricky. Number 11 is an isosceles triangle. How do I know this is an isosceles triangle? Huh? It has two congruent base angles. What they did though is they're trying to confuse you and not put it on the base, right? We're used to seeing base angles being like D and E. Not the case. They basically just turned the triangle. So my base angles are C and E, which means that this side, BC, is congruent to DE. So put those hash marks in. We're basically going to just turn our head to the side to look at it. So my goal is to find the length of DE. In order to do that, I'm going to make my sides that are congruent equal to each other. I'm going to solve for x first. So I have x plus 10 is equal to 2x minus 20. Put that into Desmos. The 3x minus 30 is just there to kind of confuse you. We don't really need to know what that is. Alright, so in Desmos you're typing x plus 10 is equal to 2x minus 20. Let me know what you get for x.
30.
Okay, does everyone have 30? Okay, did they ask me for x? No, they asked for DE. And DE is 2x minus 20. Instead of x, I'm going to plug in 30. What's 2 times 30? And 60 minus 20 is 40. So DE is 40. You will see that problem again. All right, look at 12 and 13. These also require some higher level thinking, but it's not too difficult that we can't do it. Okay, look at the yellow triangle first. Do you guys see that I have two congruent sides there? Right? So that means I also have two congruent angles. They already gave me the vertex angle of 58. I don't have these two base angles. I'm going to do 180 minus 58, and what do I get? You should get 122.
And then you divide it.
Yes, so that 122 means that between these two angles, there's 122 degrees left. But if I want to split that up evenly, because these base angles are congruent, I'm going to divide by 2. Lulu, what do you get? You get 122 divided by 2. So you get 61. So that means that this angle is 61 and that angle is 61. That's it. So I can go ahead and fill in, y was 61 degrees. Okay, so yellow triangle is done. As of now, I don't have anything in my green triangle, but I do have a linear pair. So this guy that's 61 and this other angle has to add up to equal 180. So you did 180
61.
minus 61 and you got 119, right?
Yeah.
So in this angle here, this vertex angle, you should get 119 degrees.
Are those two sides congruent?
Yes. So those two sides are also congruent because I have a hash mark there and a hash mark there. So my angles are also congruent. So if I do 180 minus 119, we already have it right here. I'm going to get 61. How do I divide 61 evenly between these two base angles?
You said
You get a decimal, which is okay. We divide by 2. What's 61 divided by 2?
30.5.
You should get 30.5. So that means this angle down here was 30.5, and this angle here was 30.5. So you guys have to remember, if an angle is side by side, it is a linear pair, so therefore they add up to be 180. All right. Let's pay attention to this number 13. What do you need? Oh, she's good with this. Do you want Angela's impact aid form?
Sure, got it.
Do you guys see that blue triangle on the left side? Let me highlight them. What type of triangle is the yellow one? That had 3 congruent sides. It's equilateral. If I have 3 congruent sides, it's equilateral. Okay. So if it's equilateral, I still have interior angles of 180, right? And I have 3 congruent angles, so I'm going to divide that by 3 to figure out what each measure is. What is 180 divided by 3?
60.
Okay, so I want you guys to fill in. Each of these angles here in yellow are 60 degrees. Okay, so I can go ahead and fill out angle A is 60 degrees. Does that make sense how we just got 60? We didn't have any numbers, but I know it's equilateral and equiangular, so all the angles are congruent. All right, look at the green triangle. Do you guys see that there's this little square here, right? The square tells me that both of these angles is equal to what? 90. If the left side is 60, what's the top side going to be? 30. Good. Because we did 90 minus 60 to get 30. It is also isosceles. So what's this measure of B? If my base angles will be congruent, what's B going to be?
30.
That's also 30. And now we can figure out angle C. Let's do 180 minus 30 minus 30. What do you get for angle C? 120. Okay, so the measure of C degrees is 120. You guys see how we just broke that down with no numbers to begin with? Okay, I gotta know that equilateral and equiangular are the same.
What is it done for letters?
Huh?
What is it doing like pop up as equilateral?
It will. I'll put those. All right, let's go back to Desmos. Number 14 says, what is the value of x in the figure to the right? If these are side by side, it's a linear pair, which means both of these angles are going to equal what? 180. So let's grab Desmos. How about you guys do this one? Type in 3x plus 60 is equal to 180. What do you get for x? Huh? You get 40?
40.
Good. That's what we got. Number 14, your answer is C. Did everyone get 40? Number 15. Who remembers what the distance formula is?
Just got. It's going with square roots. So it's square root of like x1 minus x1 to the second power plus y1 minus y2. And the whole thing is square root.
Almost. That's the closest I've heard. Anyone else remember? Okay, so distance formula is hard to remember. Okay? Let's put this in Desmos. So first, we need to get some information. What did we get for point A? What did they tell us it was?
0, 5.
0, 5. And what about for point B?
12.
12, 3. All right, everyone grab Desmos and type this in as I'm typing it in.
Isn't it like one thing, like one way?
So the official formula is the square root of x2 minus x1 squared plus y2 minus y1 squared. But like I said, that's hard for you guys to remember because we don't use it that often. I think if you guys do Desmos, it is like a lifesaver. So let's type this in. We get A equals, and you guys can use this little keyboard down here, or you can just type in the letter A. It still works. So A equals parentheses 0, 5. And what about B? 12, 3. Hold on one second. I'll help you. We're going to type in distance, space, and then you're going to type in A, B. Is that a, oh wait. Make sure you do comma. If you just type in AB, it won't recognize it. If you do a period like I just did on accident, it won't recognize it. So what is your distance? Yeah, 12, well, I would round to 12.17, or you could do 12.2. Which answer choice is best? Is F. So if you guys can remember how to do this, this will definitely help you. I will still give you the formula if you want to do it, I guess, old school. You can just type it in. But other than that, I think it's so much easier to just type it in this way. If for some reason that you forget this process, you can still use the regular formula, which is x2 minus x1. So that would be 0. Oh, wait. 12 minus 0, and you don't have to type this in, squared plus parentheses 3 minus 5 squared, and you get the same thing. So if you don't remember how to do the A equals something, B equals something, distance, AB, you can still type in the regular equation and it gives you the answer. All right, look at number 16. All right, so 15, you guys got F, right? All right, so 16. Find the coordinates of the other endpoint of a segment with the given endpoint of -1, 3 and the midpoint of 3, 1. I want you guys to write endpoint, midpoint, endpoint. We did this in Unit 1, but somehow it was just a little too confusing. So we're gonna go over the way that we did it originally, and we're gonna do Desmos. You just have to make sure that you know what they're asking you to find, okay? So for the first one, what's our first endpoint that they gave us? -1, +3. My midpoint, they gave us 3, 1. I don't know what my other endpoint was. That's what I have to find out. If you guys think back to what we did earlier, we look at my x values. How do I get from -1 to 3? We're going to add 4. What I do to the top, I also do to the bottom. What is 3 plus 4? We get 7. On the other side, my y values. To get from 3 to 1, I'm going to subtract 2. What I do to the top, I do to the bottom. So what is 1 minus 2? -1. So my answer for the other endpoint is going to be K. Okay, so that's kind of the shortcut way that we did it, but let's go to Desmos for a second. On Desmos, when it comes to midpoint and distance, slope, any of that, you can do the same thing. You can do A equals something, B equals something, And this time we're going to type in midpoint of A, comma, B. Okay, last time we did distance, but whatever word you put there, that's what your computer's going to do. So, because they gave us an endpoint and a midpoint, I'm basically going to do like a guess and check kind of thing. If they gave me 2 endpoints and said find the midpoint, well, that would be easy. I could just type in first endpoint, second endpoint, it would give me my answer. But let's see here. For A, they gave me the first endpoint, which was -1, comma 3. And it should show up on your graph. -1, comma 3. If I was trying to find which other endpoint, I'm just going to guess and check. My first option on my multiple choice, what was that, letter I, says 1, 2. So let's just say I'm going to type this in to see what my midpoint is. I'm going to zoom in a little bit. This point here is in the middle. You guys see this red?
Yeah.
I'm supposed to have a midpoint of 3, 1 according to my paper. Is that midpoint 3, 1? No. So I'm going to cross out letter B. Sorry, letter I. So I would go back here. And I would cross it out. I know that one doesn't work. All right, my next option is 2, 1. So for B, I'm going to type in 2, 1. I'm going to check my midpoint. Did that give me 3, 1?
No.
Nope. Gave me 0.52. So cross out the second option. Now we know that the third option is right because we just solved it a different way, but let's type in 7, -1. If I look at my midpoint, do I get 3, 1? Yes, so that is my answer. All right, number 17. My angle relationship there is going to be alternate interior angles. So that means they're going to be equal to each other. How do I type this into Desmos if I want to make them equal to each other? Guys, number 17. How should I type this in? We have 4x minus 30 is going to equal what? Huh? It's going to equal x because there's alternate interior angles. If you look at number 4, sorry, not number 4, number 17, they gave me this angle and that angle, alternate interior. So if you type this into Desmos, what do you get for your answer? What'd you get? 10? So your answer is C. All right, number 17. If 2 sides of a triangle are 9 and 16, then what are the possibilities of the third side? This is our inequality, okay? We did this last class. So Kenzie, this part will be fairly new to you, but I think you can pick it up pretty quickly. What I'm going to do to find my possible third side is I'm going to add my 2 numbers together and then subtract my 2 numbers together. I never want a negative, so I always do big and little. What's 16 plus 9?
25.
You should get 25. And what is 16 minus 9? 7. You guys see that all I did here was I took my 2 numbers, I added them together, I subtracted them together. So if you look at your answer, I already wrote it in the inequality for you. All you have to do is plug in your numbers. So x is going to be greater than what? What's our lower number? 7. And x is going to be less than what? 25. This is your answer. It says x is greater than 7 and x is less than 25. So any number in between 7 and 25 can be my answer. I want you guys to do number 18. I accidentally forgot to change the numbers, so I'm going to change them now. Do it the same way. If two sides of a triangle are 10 and 7, so mark those out, write 10 and 7, what are the possible lengths of the third side? Joseph, what'd you get?
3 is less than x, and x is less than 7.
7?
No, 17. No.
17. All right, so what Joseph did was he did 10 plus 7, which gave him 17, and then 10 minus 7, which gave him 3. So that means my answer is going to be x is greater than 3 and less than 17. My third side of my triangle can be anywhere between those two numbers. Do we understand what that is talking about? All right, turn the page, last page. It says, decide whether the following sets of lengths can be used to make a triangle. Show all work. What we want to do is we want to take our two smaller sides, add them together, see if it's larger than my last side. So I want you guys to write this down. 25 plus 25 is greater than 50. Joseph is saying no. Do you guys agree or disagree? Is he right? He is right. Because 25 plus 25 is 50, and 50 is not greater than 50. It is equal. So if it is not greater than my biggest side, it cannot be a triangle. Look at the second one. 18 plus 20, is that larger than 37? What was 18 plus 20? And is 38 larger than 37? Yes. And then we have letter C. I have 10 plus 15, is that larger than 20? Yes, 25 is larger than 20. So this can also be a triangle. I want you guys to do 20, A, B, and C. You can do the last three the same exact way.